we could actually produce more with the same cost by moving to this point, right? OK. All Lagrange multipliers do is formalize this necessity to make sure that every resource has the same marginal value to us in every use we make of it. And all the mathematics, when you solve for a Lagrange multiplier, is doing is determining what is the value, marginal value of that resource that is equated across all the different activities. Now, for the Cobb-Douglas formula, it turns out that when we solve out for the cost function, and I'm not going to go through and do the whole thing of this, but once you plug all this back in and you use the fact that you use things in these proportions, you get that the total cost takes this form. The key thing was that the factor proportions are that the ratio of the two is equal to the ratio of their factor shares, which is this alpha and psi, times the cost. So one way of putting that is that the fraction of all of your time that you spend on each is equal to this proportion, alpha or psi, or is in proportion to that. So it's alpha over psi plus alpha would be the amount of time you spend on academics. Psi over alpha plus psi would be the fraction of your time that you spend on extracurricular activities. OK. So mostly, we're going to consider costs in per unit of production terms. And that leads to different notions of cost. So in particular, a marginal cost is how much it costs you to produce one more unit of output in calculus terms. That is, one tiny bit more. And so that's the derivative of your total cost function. Average costs are how much the average unit you've produced so far costs. So that's the total cost divided by your output. Sometimes we decompose this into average fixed costs, if there's a fixed cost, and average variable costs. So average fixed cost is just the fixed cost divided by the output. Average variable cost is the variable cost so far divided by the output. And the total average cost is just the sum of these two things. Now, one important thing to note is that if we take the derivative of the average costs, right, we get the total cost. TC is just total cost, which is the same as C here. You get the derivative of total cost times output. That's the derivative of the top times the bottom, minus the derivative of the bottom times the top. Now, the bottom is just 1, so we get total cost prime times output minus total cost divided by output squared. And of course, the derivative of total cost is just the marginal cost, times output divided by output is just, we can cancel one of the outputs there. And here, total cost divided by output is average cost, right? So what we get is the derivative of average cost is equal to the gap between marginal and average cost divided by the output. Now, why is that intuitive? Well, let me tell you the story of how I met my wife. So I was taking a Latin American politics class my freshman year of college with her. And I was in the class with only 4 other freshmen. Now, at the midterm, the professor came in and said that the freshmen had done better than any other class on the exam. And I was really surprised because I had done well, but I knew 3 of the 4 other freshmen, and they had all come to me for help on their exam, and it was pretty clear to me that they, had maybe done OK, but weren't going to be enough, even with my score added in, to be above the other classes, right? And so, but I didn't know who the last freshman was, right? I realized, though, that if the average among all of us was that high and that much higher than the average of just the four of us, that the marginal, the woman who ended up being my wife, had to be very high above the average, right? And so that's the basic intuition that's behind this thing that the marginal pulls the average, right? Because the marginal has to be higher than the average in order for the average to be going up. And I ended up becoming an economics professor teaching you about marginal and average costs, and she ended up becoming a Latin American political scientist. So it was very fitting. OK, so total cost is a curve that we rarely draw out. So it's not going to be something we focus on. But again, you can decompose it into fixed and variable components. OK. So I'll just draw these out just to give you a sense of what I just said. So a typical shape that you might have is that the average fixed cost is just the fixed cost divided by something. So it sort of comes down like that, right? The average variable cost could have any shape you want, but maybe it's just, say, increasing like that. Then the total average cost is going to be the sum of these two. So it'll be maybe something like that, right? Marginal cost has to drag this fixed cost, right? So, I mean, this average variable cost. So it's got to be above it if it's increasing, right? And it's got to intersect the average cost at its minimum point, because it's got to be dragging the average cost as well, right? So this thing's decreasing whenever it's below it, and then it's dragging it up after that. So it should be there. OK. Now, I want to give you some examples of cost curves that economists actually use in the real world. So one example of a cost curve was studied by Athey and Nikiforov in a recent paper on online ad auctions. And the reason I want to talk about this example is it's not something that you would immediately think of as being a cost. But remember, all that a cost is how much it takes to get something. So here's the question that they thought about. They said, imagine that I'm bidding in an online ad auction. What are those? There are these keywords that people search for, like car insurance or whatever else you do, date night, right? And people want their club or their auto insurance company to show up on the right-hand side of the page on Google when you Google those things, right? And in order to do that, they need to bid for those things. So in particular, there's an auction that Google runs every second, basically, which says who's currently bidding highest for a given word. You're going to show up on the right-hand side of the page. But the thing is that there's many different spots on the right-hand side of the page, and people all want to be at the top, not a little bit lower down, right? And the reason you want to be at the top is you're more likely to get clicked on if you're on the top. And the way that you bid is you bid a price that you're going to pay to Google for every time that you get clicked on, right? Now, the way Google determines who goes where is they assign things to the person who has the highest product of the bid that they make and how likely Google thinks it is that you'll get clicked on. Because that's how much revenues Google is going to get, is how many times you get clicked on multiplied by how much you pay for every click, right? And they figure that out based on their experience with the word, with your ads, et cetera. They have a whole bunch of things that help them determine how often it's likely that you get clicked on, right? Whether the ad is annoying or whether it's useful is another thing that affects this. And what that means is the higher I bid, the more money I pay, but also the more likely I am to get clicked on, the more clicks I get. So a natural thing you can ask yourself is, if I wanted to get a certain number of clicks, how much would I have to pay? Right? And that defines a cost curve for me. Right? The cost of getting a certain number of clicks is bidding at a certain level. Right? And so from this, we can derive the marginal cost of getting clicked on. And that's what's relevant to a firm, right? Because if a firm is going to make a certain amount of money for every time they get clicked on, they want to set the marginal cost of buying a click equal to the value that they get. That helps them determine what's the optimal amount for them to bid. They can determine how many clicks they want to get, and then they can go back through this and figure out what actually should I be bidding to get that. And Athey and Nikipolov estimated this on a keyword, something like car insurance, and here's what they got. They found that if I want to get a certain number of clicks on average, I'm going to have to bid I'm going to have to pay this amount here, right? And that, if I take the derivative of this using the formula that we had before, will give me this marginal cost. And then I can intersect that with the value to me of getting a click. And that tells me the number of clicks I want, the total amount that I'm going to pay, and then if I divide those by each other, how much I should bid. Right? So this gives a simple way to use economics to think about what's the optimal number of clicks for me to buy and the optimal bid to enter in the auction. OK. Another example of this, which again might not seem your most direct way of thinking about costs, but shows how flexible this is as a way to analyze things, considers the cost to the government of providing insurance coverage to people. Imagine the government or your company or some other sort of monopolistic person was going to provide insurance, right? The quantity then is what fraction of the people are covered by insurance, right? In order to get more people covered, you're going to have to lower the price, right? And as you do that, you're going to get more people covered. And that's going to have some cost to you because those people will be sick to a certain extent or not, and you're going to have to pay for their insurance, right? Now, this would, if everyone was the same, if all the people who were willing to pay more and less for insurance had the same health risk, this would just be completely constant, right? Because as you got more people, the marginal cost of getting one more person would be completely constant, right? But the story that economists usually tell is that the people who are willing to pay most for insurance are the people who are most afraid of being sick. If that's the case, then this cost curve, the marginal cost, is going to decline. Because the first people that are going to want to buy insurance are going to be the most costly. The next people will be less costly, and so forth. This is called adverse selection, or the lemons problem, right? Another way of thinking about this is what's called Gresham's law. So Gresham's law says that imagine that there's like a coin that's really valuable, like it's made out of gold, and there's another one that's not valuable, it's made out of copper, or it's like paper money, right? If you force them to be traded at the same price, everyone's going to hold on to the gold coins and trade the paper money, right? And so the people who are going to be willing to trade at any given price that you offer are going to be the people who have the crappier value currency, right? And it's the same thing here. Now, that's not necessarily the case. In fact, things could go in the opposite direction in the case of insurance. Why is that? Well, imagine that it's true. People who are more sick are more likely to want insurance. But also people who are more paranoid about their health are likely to want more insurance, right?